Okay, so yeah, I'm David Clarke. I'm just a really enthusiastic homebrewer. I'm currently the Deputy Brewmaster for the Babs Club. So yeah, come and have a chat to us, and we'll basically spend my spare time hanging around breweries, brewing beer, looking on internet forums, talking about beer. We try to fit in work and family, but it's a bit hard sometimes. But so today we're talking about one of the key ingredients in making beer. That's the water. So I basically doing this talk today because I gave this similar talk at our club, and we did a bit of an experiment with the same beer with different water profiles, and just sort of I've got the science background, so I ended up talking today. So today's talk, I'm going to have to smash through this so we get to our morning beer session. So I'm not going to keep up the slides for too long, and we'll just these will be available later, I believe, online, so don't freak out too much if I go too quick. So I'll quickly talk about why we'd want to worry about the water, some simple improvements, a little bit about historical brewing cities, constituents of interest, touch on pH, hardness and alkalinity, the residual alkalinity and beer colour, mash and beer pH, which brewing salts you might like to use, just quickly list some tools that are available. We'll have a look at Brisbane water. Probably skip over some stuff to remember, acknowledgments, and some other things we can think about doing in the future, and then we'll do questions later in the session with everyone else. So why worry about water? Basically because John Palmer told me to. In 2008, when I bumped into him at the conference and he did a talk on water chemistry, he couldn't believe that I wasn't already doing it, having a science background, so he wrote this in the front of my copy and sent me home. You don't have to worry about water, that's the first thing to say. You can still make great beer. But because brewers have been doing it for thousands of years, they didn't know anything about pH, water constituents, thermometers even, enzymes or anything like that. So, and they were making good beer. It's one of the 4 ingredients that makes up beer, and it can be up to 97%. And it could ruin your beer, so you might want to think about it. If you know what you're starting with and you understand it, you can improve and you can match to the beer styles and flavours that you're actually trying to achieve in the final beer. It does affect the mash pH, enzyme activity, the clarity, flavour expression, yeast health, and the final beer pH, which is really important. And you need to know a little bit about brewing chemistry if you want to start adding salts. So the simple things to start with, and this goes for kit and all grain brewing, is that you've got to start with good tasting water. It's got to taste good, be free from odours, or it's no point really trying to make a beer out of it. So town water, you want to think about removing the chlorine and chloramines from the water. So boiling will do that mostly, but extended boiling would remove the chloramines, so you'd really need to use an activated carbon filtration system to get rid of all those. When I was doing kits, I did about 100 or so of them, and I think one of the biggest improvements I had with the kit beers was boiling the water and cooling it before use, because it was removing I didn't know why, it was because it was removing the chlorine, I guess, and it made a massive difference to the end beer. Also, you might want to, if you've got tanks or whatever, you consider that it's capturing whatever's on the roof, or, so bat poo, whatever's on there, rust. So just keep that in mind, so if you're just using that, you can pre-boil water, filter, you can use Camden tablets, which is the potassium metabisulfite that kills the chlorine and chloramine in the water. Home filtration systems, you can get RO units. There's plenty of keen home brewers that have got those now that strips out everything out of the water, so you can start from scratch. Distilled water, you can buy that. You can buy mineral water, but just be careful because you're not really exactly sure what the mineral content is unless it's listed or you get a thing off the company. Basically, you can't really talk about water without talking about sort of how it all came about. Historically, beer's a regional product, so the beers and sort of developed in different regions on what was available, so the local malts, water, taxes even, depending on sort of drove sort of what the beers, how they were being made. And beer styles did develop slowly over time in certain regions because they could make a beer taste really good, and water did come into that. So scientists began to investigate that, what was in the actual water. So we won't spend any time on this slide, but it's just showing you that there's, all different regions around the world, fairly famous regions, beer styles and different components and levels in the water. So probably, if you remember anything from today, remember that calcium is an important mineral for the water. So it's the principal water hardness mineral. It lowers your mash pH when mixed with the grain, promotes healthy enzyme activity, assists with protein flocculation in the kettle. It's important for yeast function. It's helpful for beer stability and clarity. And you should aim for about 50 parts per million in all beers. Okay, magnesium is similar. It's water hardness. It's also an important yeast nutrient. You don't want to go too crazy because it'll start to impart a sour taste and also laxative effect above 125 parts per million, so you don't want to be going to the toilet. So you target 10 to 30. Sodium, it can round out beer flavours at low levels and accentuate the malt sweetness. Basically, obviously if you go too high, it's toxic to the yeast and it's too salty flavours in the beer. Another important group of things is the carbonates. Basically, they're the alkaline buffers, so they have a huge influence on the mash pH, and these are in Brisbane water, so I'll show you that later. They neutralise the acidity from the dark grains, and there's a little bit of a list there of what sort of levels you might aim for in the different beer colours. And just a note here, you can't really brew too many beer styles well with high alkalinity water. So I don't think there's too many commercial breweries that will be adding alkalinity to their water, I wouldn't think. Sulfate's one you want to think about if you're a hophead. It accentuates the bitterness and makes the beers seem that drier and crisper. Famous water region is Burton-on-Trent, and the sulfate's one of the main reasons why it has that sort of thing. So there's the targets again, 50 to 150 in most beers. Some higher levels if you're going for ESBs and your APAs and IPAs and if you're trying to Burtonise your water. Just be careful if you get too high, and you may want to consider it as a ratio with the chloride. It accentuates flavour and fullness to the beer and can emphasise the malt character. Again, target ranges, don't go too crazy because you get medicinal flavours, and consider with the sulphate. How much time have we got? pH basically is the scale, a balance between the acids and the bases in a solution. So pH of 7 is neutral, anything lower than 7, so less than 7 is acidic, greater than 7 is basic, alkaline. You can see I've got a little picture there from Wikipedia that's sort of got a little bit of a list of some of the things around the house that give you an idea of what levels you're at the high and bottom end. If you put your hands in that kind of liquid, you're going to lose your skin. It's basically what it actually stands for is the negative logarithm of the hydrogen ion concentration. So pH 4 is 1 by 10 to the minus 4 of the hydrogen ion concentration, and pH 5 is 1 by 10 to the minus 5. And what that means is that it's a 10-fold difference between a pH of 4 and 5. It's not linear, so it's multiplied by 10. Okay. Target mash pH, this is something important as well you want to remember from today's talk of anything else. At room temperature, 5.4 to 5.8. And at mash temperature, it's 5.1 to 5.5. So when you're reading a book or you're referring to some document or some sort of information online or whatever, or you're talking with other brewers, just make sure you're talking about the same thing, room temperature or at mash temperature. Basically, just made a note there about the automatic temperature correction. That corrects for the temperature of a solution at the different temperatures. It doesn't account for the fact that the pH actually does change at different temperatures, so it doesn't correct for that. So there is a difference when you're using an automatic temperature compensated pH meter. So just basically let the sample cool and measure it. That's the easiest way. It's basically mashings, you're going to be reasonably close to that target range with any water profile unless it's really terrible. It's because malt is an extremely powerful buffer of pH due to all the constituents of it. And no text or homebrewing books written by very well-respected commercial and homebrewers agree on their favourite target range or exact favourite pH. So you just got to experiment a little bit and find what works for you. So far in my brewery, around 5.4 to 5.6 at room temperature. Why is it important? Just have a look at that diagram. It just shows you that red band. It's kind of like, look where all those enzyme groups are all just around there. They all work at, they work better at those temperatures, so, pH, sorry. Okay. Basically, why is the mash pH important? Well, we're trying to convert the starches to sugar, so the enzyme activity is quite important. And also, you might want to think about it if you're with your sparging, rinsing, your pH, you don't want it to get too high, otherwise you start extracting too many tannins. You can think about it as well, the boil pH and also can affect things, so there's a bit of a balance there. If it's higher, it's better for isomerization of the alpha acids, a little bit lower, it's better for protein flocculation, so you just got to be careful. Everything in brewing is a bit of a balance. It's important for yeast development and healthy fermentation. And the most important thing, I guess, is the mash pH actually drives the final beer pH, and that's where you get your flavour expression, so it's really important. Hardness, basically when your soap doesn't lather, so don't let anyone tell you that hard water is terrible for brewing. It's actually quite good, as long as it's not too hard. Temporary hardness with the calcium carbonate in it can be precipitated out by boiling. Permanent hardness could be considered to be the calcium chloride and calcium sulfate, and it stays up even if the solution's been boiled. I wanted to quickly touch on residual alkalinity. It's the ability for the alkalinity is the solution's ability to buffer acid addition. So it's actually a measured thing. So you actually add a specific concentration of nitric acid to the sample and basically go to an endpoint. So what will actually happen, and then it's put on the water report as a, it's actually described on there as calcium carbonate. Total alkalinity is calcium carbonate, so everything's sort of in the same units. It's a brewing term, German scientist Kolbach. Okay, there's a formula there, and you don't need to remember that. It's all in free online calculators for you, and but that holds true to today. That's that formula. So it's got this nice diagram here. The grain bill. So what grain you've got, the water hardness, so your calcium and magnesium, and the water alkalinity actually drive your mash pH. So those are the three things you're considering. If you added distilled water, which has got nothing in it, to base malt, you get a pH of around 5.7, which is still in that desired range. And if you added a malt bill with lots of roasted grains, it would push, and distilled water, it would push the pH outside of the range down to sort of the low fives. We've got a John Palmer's residual alkalinity nomograph actually online as a flash application. So you have the Brisbane water profile configured on the right-hand side. It draws all the lines for you, and you can actually change the salt additions on that screen, and it'll actually change the what sort of coloured beer. It's like pointing to that sort of amber coloured beer, or dark amber through to sort of red there. That's the sort of best sort of beers you could brew with Brisbane water. So that'll tell you that if you brew a beer in that range, you'll get the correct mash pH as is. If you want to brew something darker or lighter, then you might need to make some adjustments. It's okay, we'll keep going, I think. There's a sort of 6 brewing salts you should have in your cabinet, or you may not need to have all of them. So I won't go through everything on that screen, but basically there's six to consider: calcium chloride, the chalk, gypsum, Epsom salts, your good old table salt, and baking soda. Just quickly added this one. I've just put here, most of us are making a single batch of 5% beer. We've got 5 kilos of grain, 13 litres of water in the mash. Just put here that if you're targeting, say, 100 parts per million in your beer of calcium, you'd want to add about 4 grams of gypsum. It'll add 72 on top of the 23 that's already in Brisbane water. So that sort of gives you an idea, and that'll also bump up the sulphate level. So it'll just over 200, so you'll have a chloride to sulphate ratio of 1:3 or something, so that's quite good for a hoppy beer. Just be aware if you're using teaspoons and you're not measuring things, that a teaspoon's not a teaspoon because all the different powders have different weights. There's just a couple of ones on there. So the chalk, for instance, is only 1.8 grams in a whole teaspoon. What if I don't hit my target pH? You can add lactic acid, phosphoric, citric. These are all food grade, easy to handle, safe, kid friendly. Hydrochloric, sulfuric, you don't want to have those things floating around, but they can be used. Sodium bicarbs are a really cheap and effective way to quickly add some alkaline to your mash. You could use calcium carbonate if you wanted to, but solubility is limited, and it also has a calcium component, which is trying to force the pH down, so you're kind of taking 2 steps forward, 1 step back kind of thing. Again, caustic you can use, but you probably don't want that floating around your brewery if you've got little ones like I have. Other stuff to consider, add the salts directly to the mash. Go easy on the salts. You're talking about grams here for half a teaspoon, that sort of thing. Can you use 5-star? Of course, but what are you trying to achieve? If you're just wanting the pH, then that's fine. But if you're wanting to add salts to get flavour, then you want to consider that as well. You can do things like adding acidulated malt, doing sour mashes to bring pH down. Do I have to worry about pH in the sparge water? Well, I've done a few experiments with that, and basically the pH doesn't raise above 6 until you do about your 3rd batch sparge. So I'd say probably not with batch sparging, but if you're fly sparging, which is continuously rinsing, you may want to consider testing the pH and checking, making sure you're not raising up too high. Why is it important in the final beer? So we want 4 to 4.5 is the best expression of all flavours and textures. So too low, it's harsh, astringent, one-dimensional, and too high, it starts getting soapy, muddled, a bit dull. I quickly talked before about the tools. They're all free, available online. I've got copies here. We'll probably pop them up on the website as well. Even Beersmith has it. All those brewing software things have all the water chemistry tools in them. So Brisbane Water, when John was here a few years ago, he basically did a whole thing about Australia, and he drew a little diagram as to where we should be brewing our beers in the range. And I'd say we're probably from that sort of amber to sort of brown ale kind of area where we can brew those without even worrying too much. I did a little bit of running around myself and got some Brisbane locations. I've got a colour chart on the side. It sort of matches up to the EBC for the sort of target EBC, which would be the right pH for these sort of areas. So if you've got, basically I've been onto the water authorities in the last sort of month as well, trying to find out more detailed information, more regular information. I don't want just a yearly average because that's generally what you get. So even though you get told this is the water profile for this region, it's just it'll give you the yearly range. So what comes out of my tap today could be totally different. So that's why you should consider checking with our pH papers or pH meter. And there's a lot of water done in bulk for Brisbane. So I don't know about the rest of the state, but there's like sort of 4 main areas, and they do enormous amounts of water. But then after that, it goes on to local treatment plants, and I tried to get all the treatment plant information. I got about half of it yesterday afternoon after I'd handed in my talk in. So of course that was going to happen. But I'll try and make that available as well. So I think we're running short on time. I did the rest of the state. Is there anyone here from any of those places? Bundaberg maybe? Toowoomba? I'd like to live in Cairns. There's absolutely nothing in the water in Cairns, so you'll be able to, it's like starting with a clean slate. Rockhampton's not too good, I don't think, is it? All right, keep going. We did an experiment at our club. We basically did the same beer, 3 different water profiles, reverse osmosis water, we simulated Dublin water by adding calcium carbonate to Brisbane water, and we did Brisbane water straight at the tap. All the beers were close, but we did have some differences. The Brisbane water came out a bit more malty in the aroma. The Dublin one was a bit drier, and the RO water had a bit of a struggle in the fermentation, finished higher, and it was a bit watery, even though it was finished at a higher final gravity, and there was no aroma whatsoever. Pretty insipid kind of beer, really. That's not really that important. Take-home messages. Brewing's a very robust system. Be happy with Brisbane water. It's excellent for brewing most beer styles. It's probably not too good for pale lagers, so you might want to consider at least removing the chlorine, but perhaps cutting the water with distilled or getting an RO system or whatever. The mash pH depends on the water chemistry and the grain bill. Beer pH depends on the mash pH and the fermentation. If you don't have a problem with your brewing, don't try to fix it. Good water chemistry won't fix bad processes in the rest of your brewery. It's not a magic bullet. It's part of the puzzle of being a complete brewer and going on your journey of making good beer, and it can make a difference. There's some excellent information online, podcasts, books, free software. Sort of have a look at all this stuff I've talked about. I've just touched on everything. Thanks go to the Melbourne boys. They helped me with the experiment we set up, and thanks John for the wake-up call. Some more things to consider in the future, just experiments and things we're planning. So pale lagers and how much sulfate's too much. Does the chloride and sulfate ratio have that much of an impact? Looking at absolute values and ratios, and maybe doing some more Pilsner stuff with the RO water. And we'll do the questions a bit later, I think. So, thank you.